Hello and welcome to this network education video. My name is Russell DeLong and this is SS7 and Sigtran. Now this can be a bit of an intimidating topic to cover as an IP networking person because this is really the core subject matter of traditional telephone signaling. I'm really talking about a technical culture other than my own in this video, so I'll be treading a bit carefully here as I try to make sure I do this subject matter justice. It's just a really critical topic in understanding the foundations of where a lot of mobile signaling protocols, past, present, and future, are really coming from. And for a course on the EPC, even though this might all sound a bit sidetracked, it gives important context to some of the things that are going to be coming up, like diameter routing, interworking function between the EPC and any pre-release pre-3GPP Release 8 networks, circuit switch callback, call flows, for sure. I could go on, but really the point here is that within mobile, knowledge of SS7 really will help you. So this video seeks to cover an overview of the PSTN and the SS7 protocol suite, a breakdown of how a call is set up in the PSTN over SS7, an explanation of how legacy mobile wireless fits in the PSTN, and an introduction to Sigtran, that is, signaling transport, and the carrying of SS7 over IP. So first of all, just to dispel some misunderstandings, especially within the IP community, SS7 is not a signaling protocol. SS7 is not a routed protocol. Rather, SS7 is a protocol suite, or a reference model, a collection of protocols that operate on different layers that serve different functions to provide for end-to-end network connectivity. Similar to the TCP/IP reference model or the OSI reference model. And they map out kind of like so here. So this is the OSI model on the right and SS7 reference model on the left. Just to note as well, the SS7 model here I've drawn the names of the actual protocols themselves as opposed to the layers necessarily. So physical and data link, layer 1 and layer 2, map to MTP, layer 1 and 2, that is message transfer part. Closest analogy I would say I could give to MTP2 would be the point-to-point protocol, for example, in IP. At the network layer, it's actually quite a bit different. We're going to be talking about this a lot, but this is MTP3 for your routed protocol, but also SCCP as a routed protocol, and they work together. This is not an alternate. It's not like having IP version 4 as opposed to IP version 6. These two will actually help each other, and we'll talk about that. SCCP is actually a sometimes. You can use MTP3 without SCCP in some examples. I'll give an example of both. And when SCCP appears, it's directly above MTP3 in the stack. Transport layer, I should almost draw it as a dotted line. I would say to, sorry, I misdrew the dotted line, to SCCP. SCCP, and we're going to really illustrate this, it provides application layer awareness to MTP3, really. So SCCP has, among other things, what's called a subsystem number, which acts kind of like the port number at a transport layer in the TCP/IP reference model. So how TCP and UDP would have a port number to indicate what service or what application is coming up, well, SCCP has a subsystem number that serves the same sort of purpose. Session layer, there is more of a division between session layer and the application in SS7 than there is in TCP/IP, where they're all just sort of merged as the application layer. TCAP is used in some applications, not all. Some applications have their own session layer. And then application and presentation, I'm going to put with ISUP, map, etc. So for SS7 terminology, my plan is to go over the basic terminology, and then we're going to be going over some diagrams and some call flows to sort of drive the concepts home. So first of all, the basic three network elements, and really I could draw a fourth there for SDP. You have the SSP, or signal switching point, that is more commonly referred to as a switch or a telephone switch. That is what is doing your call processing and your phone registration. So if you or I guess really the IP equivalent would be like a Cisco call manager or unified communications manager or an asterisk server in a VoIP network. So if you pick up a phone, your dial tone will be given to you by a telephone switch. That will be the SSP. He will be the one to decide where and whether to route a call. If you dial a number, he'll be the one analyzing the numbers that you dial and determining what other SSP or what telephone switch needs to receive your setup requests to talk to the other phone on the other side. An SSP will send its messages when talking to the PSTN for signaling to an STP, that is a signal transfer point. So he's just responsible for transferring messages, or really routing messages. An STP is roughly the equivalent to an IP router. He makes forwarding decisions at layer 3, just like an IP router, and you can go back MTP3 and SCCP. So he cares about source and destination point codes in MTP3, and he cares about global titles, potentially, at SCCP layers. And an SCP is a signal control point. A signal control point really can be used to provide instruction to an SSP. So if an SSP needed to know how to correctly route to a 1-800 number range, he could query an SCP and have that translated. If an SSP wanted to confirm if a subscriber had enough balance in their account to be routed, he could query an SCP. An SCP can provide intelligence to the network. It is part of the IN, or Intelligence Network, IN. You'll hear that term almost used synonymously with an SCP, and that's sort of part of the SS7 network architecture. An SCP might run protocols like INAP, or IN Application Part, or CAML, or CAP, as I believe it listed here as CAML Application Part. And those kinds of protocols provide intelligence from the intelligent network to an SSP, or a telephone switch. An MSC is a mobile switching center. An MSC is really just a cellular wireless specific SSP. So this would be part of the pre-release 8 architecture, an MSC, where when, I guess, before you had an all-IP network in mobile, before you had the evolved packet core, you had the, I guess, pre-evolved core, which was half packet and half circuit switch. So an MSC would be the basically the call manager for a circuit switch older architecture mobile network. But he would be an SSP with some mobile specific protocols. Now a B number is the destination phone number being reached. So if you pick up a phone and dial, you would be the A number, or your phone number would be the A number, and the destination would be the B number. You'll hear that used when talking about switching. So you would look at let's say a B, how to relate it. B number analysis would be kind of like an IP routing table lookup, where you're trying to determine what route to use to send to a destination's telephone switch to route a call based on the B number that was dialed. That's B number analysis. So the term B number and A number are very commonly used when talking about telephone call flows. Point code, I think I mentioned a little bit ago here, but a point code is like an IP address at the MTP3 layer. Yeah, so similar to an IP address. It is a well, I should say it depends on the area, but in North America it would be a 3-digit dot decimal number. So you can sort of go here, MTP3, you've got, like for example, 1.1.1, maybe an MTP3 address in North America with an ANSI standard. You would see a European ITU standard elsewhere. You'll see China has its own standard, Japan has its own standard. So it's not like IP version 4 where it's the same protocol with the same 32-bit address all over the world with IP version 4. Here you have a 24-bit identifier. In North America you have different numbering ranges in different regions. GT is a global title. A global title is a unique identifier in the SCCP layer, and it typically relates to a specific application. And we'll see a couple good examples of that coming up, I believe 2 slides from now. So really the relationship between MTP3 and SCCP is one of the more difficult concepts to understand in SS7. So my approach here is going to be to give you an example of a pure MTP3 call flow, And then we're going to talk about a more complicated mobile call flow where we're going to be using SCCP to kind of help MTP3 deal with a more difficult situation. Called and calling parties. So a calling party in a number of different SS7 protocols is the source. Called will be the destination. That's the terminology in PSTN signaling, and it carries over to a few other protocols actually. I think it might have started with PSTN, but calling is the source, called is the destination. You will also hear the term call spill into data a little bit, sometimes sort of as jargon incorrectly. But if you talk about the LTE attach procedure or the EPS attach procedure, creating an EPS bearer, I'm not sure what order you're watching these videos in, but creating an LTE data session, you would actually hear that commonly referred to as setting up a PS call or a packet switch call or a data call. Even though you're not picking up a phone and dialing a number, that's sort of what is relatable to how you would set up a service in a circuit switch telephone network. Now links, routes, and sets of links and routes. So I sort of gave a description here, but just to go down to sort of illustrate it a little bit better, I went with green, I drew the first one already here. So if you have a layer 2 connection between two point codes, so point codes being your IP address, so 1.1.1, 2.2.2, you've got a direct link between them. So your next hop at layer 3 would be 2.2.2 if you're 1.1.1. Well, you could say that you have a link to 2.2.2. If you have multiple layer 2 connections, so I will go, that's slightly different green. I'll just pull this over. If you have a second connection to 2.2.2, a second redundant link, you could say that you have a link set to 2.2.2. And let's say you have a link set to 4.4.4. And they might have links to 3.3.3. Now I'll use blue here to talk about routes. Now if you have it configured in 1.1.1 that if you need to talk to 3.3.3, you can do so via 2.2.2 in a path like this. You could say that you have a route to 3.3.3. And if you had multiple redundant routes to 3.3.3, like so, you could say that you have a route set to 3.3.3. Now, this is the terminology in SS7. It's a terminology you'll see a lot in like fault management and operations. You could say, like if someone were to tell you that you have a route set down, that would mean that this source, 1.1.1, can't reach destination 3.3.3. And it also sort of indicates loosely a level of priority in an alarm. So a link being down would not be necessarily as bad as a link set. A route would not be as bad as a route set, because a set would mean that your redundant links are also down if you had any. However, this can get a little bit more complicated than it might sound. I mean, it might sound straightforward, but where this becomes tricky, you could have one link here, for example. Or I shouldn't say tricky, but at least a little bit misleading. You could have one link here between 1.1.1 and 2.2.2. So you could say that you had a link set with one link. You could say that you had a route to 2.2.2 via your link set. And you could say that you had a route set to 2.2.2 with one route. And within that route you have one link set, and within that link set you have a link set of one. So you can use that terminology to map it quite a bit, even though you might only have one link. You could say that all four of those things might be down if you pulled one cable between 1.1.1 and 2.2.2. Alright. So this is just a simple SS7 network that I drew here. Similar to how in 3GPP, if you saw the EPS call flows yet in the order you're watching these videos, how you have different interface names, like a link between a device and the radio would be a UU interface. The link between the eNode B and the MME would be an S1 MME interface. Similarly, in the PSTN, you have link names. So you have this SSP to STP. You could call that an A-link. That's probably a little bit too thick. So this could be called an A-link. This would also be called an A-link. If you had a pair of STPs that were sort of acting redundant towards each other and they had links between them, you could call them a C-link. This STP to this STP, you might be able to, depending on the topology, you call this a D-link. There's a few different links that refer to the sort of the logical purpose of the connection between the network elements in an SS7 network. But here we're just going to go through a basic phone call setup. Now here we are going to use ISUP or PSTN user part, so ISUP signaling between two SSPs, where this party, this A person or A party, is calling this B party. So left-hand side, and I apologize for the appearance of it, but this is intended to be a telephone, and this on the left side, and this on the right side is intended to be a second landline telephone. So if a user picks up this phone and starts to dial a number, and then dials the phone number of this B party, this B number, let's say it's 5555. I don't know why I'm putting it in dot decimal there. I'll just try it as 5555. Obviously, if it's over the PSTN, it wouldn't be 4 digits, but let's just use this as an example. He dials 5555. The SSP, the signal switching point, or his telephone switch, is going to analyze that B number that you dialed, and he's going to perform B number analysis. So he's going to look at his B tables and determine what destination point code he should route this message to. So let's say this guy is point code 222, and this guy is point code 111. He would send a message at MTP3 layer of source or originating point code 111 and destination point code 222. The STP would then look at his routing table and say, well, in order to reach 222, I have a route in this direction. You might have another route in this direction. You might be configuring priorities between your two routes and your route sets. But STP to STP, he might have a route that he's using to go this way. And this STP would have a route to that point code. And so the SSP on the right-hand side would see destination point code 222, and that would prompt him to look up into the next protocol layer. So in this case, we're talking about an ISUP call. ISUP does not need TCAP, and we'll use an example that does need TCAP upcoming. And ISUP also does not need necessarily SCCP. This is a simple case, and again, we're going to talk about a little bit more complicated case immediately afterwards. So here we're just talking about MTP3, and above it is ISUP. So at an MTP3 layer, you have an SI, or really a protocol field, that says what application is coming up next. So in that message, when this SSP read it, he not only saw his destination point code, but he saw that the next protocol coming up was ISUP. So he interpreted everything else after that in the stack to be ISUP, and he looked at the called party, the destination, and he saw that it was 5555. So the SSP looked at it and said, I have a line that's provisioned with 5555. I'm going to ring that phone. I'm going to provide line voltage, and I'm going to ring that phone. Subscriber, this B party, here's the phone ring, picks it up, that gets to the SSP, says, okay, the subscriber's picked up. I will now send a reply back to this SSP. Now, I'm trying to avoid being application specific, but ISUP is pretty standard, so you could say that this is the IAM was the first message, the initial sort of like a SIP invite, and the ACM response back. So they're talking back and forth to set up this call. And then there's error handling and everything else, like if this subscriber never picked up, this SSP could send a release saying, the subscriber is not picking up, and the user on the A side could hear an appropriate error response, or being given a busy tone if the SSP indicated that the subscriber is busy. All the signaling happens. Now, the reason that ISUP does not require TCAP in this protocol stack is because he has basically a session identifier called a CIC. So when he got that IAM message at a CIC, and they're using that number in the value of that CIC field to differentiate between different sessions. So if you've got 4 or 5 calls being set up between these SSPs, you would have different CIC numbers to distinguish them. Now, all of that sets up a call. It is not the path of the call, though. Path of the call will be something like this, and there's a lot of drawings here already. Path of the call will be something like this, that green line. So yes, you would be sending your voice traffic to the SSP, or I guess logically, it could be to like a voice gateway or something that the SSP is connecting to, but your voice path is going to be between these two telephones, between these two operators, independent of the signaling messaging that's happening here. So this could be through like a T1 line or a DS3. It could be SONET, like an OC48 or an OC192, depending on the capacity and the number of calls that will be happening and needed to be switched across between these two SSPs. But the idea I just want to emphasize here is that you would not have voice payload crossing an STP like this. This is all signaling. This is all PSTN signaling, independent of the actual voice traffic going across. So here you have a slightly more complicated case. Actually, I'll draw. Yeah, I started getting ahead of myself here a little bit. Sorry. So let's say you have a subscriber who's trying to register with a mobile switching center. So similar to in the Evolve packet system, where you have a device that tries to register with an MME in the EPS attach procedure, well, here you have a subscriber that's trying to register with an MSC. And let's say this subscriber, this is supposed to be a cell phone here, I'm sorry. This lightning bolt is a radio to the cell tower, the node B, talking to a radio network controller who's going to forward this registration request to the MSC. Let's say this subscriber belongs to operator A. His SIM card is that of operator A. And the MSC in this network is operator B. And then this HLR is operator A. This MSC needs to be able to receive a registration request via what's called a RANApp application, or just a mobile-specific application, in order and read that message and be able to route somehow a request to an HLR to figure out what security information exists for the subscriber to authenticate him, to prove that this is the A party, to prove that this subscriber is provisioned for services, that he's not barred from his own carrier. His own carrier isn't saying he doesn't have service. He needs to confirm that he has service from an HLR, confirm what services he should have, and he needs to confirm his authentication information so that he can prove that he really is the A party. Or A party. He really is subscriber A, or wow, I keep screwing that up, but he is this subscriber that he says he is. So in this message that A sends to try to register with the MSC, the subscriber is not going to know his phone number. This whole concept of the PSTN and routing on, like this whole concept of B number analysis, well, he's not calling a number. He's not calling some other telephone number. He's just saying, I want to register with this MSC. So this isn't a phone call. This is the use of the PSTN and routing over the PSTN to talk to some other network element. Quite a different case, and it's application specific at that. The only information this subscriber is sending the MSC really is the IMSI number, or IMSI, of the SIM card. So let's say that's 234, I don't know, then a whole bunch of numbers. So it could be 14, 15 digits, whatever, but that's the IMSI number. That's all he has to go on. So in order to deal with this, the MSC has to use application level routing, really, and he has to use the SCCP protocol and the use of global titles to figure out ultimately how to get to this HLR over the PSTN. So he needs to rely on some STP somewhere that can perform global title translation at his next leg. So he's point code 111, and let's say this is STP with point code 222, and this HLR is 333. He has no way to derive 333. PSTN is nothing like DNS or anything like that that the IP network would have to resolve IP addresses from faraway systems. So he needs to figure that out by just querying the STP. So he's going to send at an MTP3 layer a message with source 111 and destination 222, which is really a request for the STP to help at the next routed protocol layer. So the STP is going to get the message at an MTP3 layer. It's going to say point code destination 222, that's himself. So he's going to look at the upper layer. The protocol field at MTP3 is going to say that the next upcoming protocol is SCCP, so application type routing. The STP is going to look at a couple things. He's going to look at the subsystem number, which is like a port number. So this is almost, you can almost think of this as policy-based routing in the IP world. So he's going to see SSN equals 6. So I'm trying to talk map, mobile application parts, the application that happens here, to an HLR. That's identified by this SSN 6. So I need to do routing for SSN6, and the global title, that unique application-specific identifier, is going to be this IMSI number. So in STP, this guy could be default routing. He might be a more intelligent STP depending on how far away he is from this HLR. Like if this is a whole other country, let's say this is North America. Let's say this is North America. There's a big cloud of STPs, and then this is Europe. He would probably just be default routing potentially to an upstream STP. There's actually a hierarchy of STPs. You have national STPs, gateway STPs, and then international STPs, and then another gateway layer, and then the next national layer. So that's sort of how they have interworking between point codes in China versus point codes in Japan versus point codes in North America. But in any case, this STP is going to look at this and perform some kind of a translation function. It could be as simple as this. The IMSI starts with a 2. That means he's going to Europe. So I could write a dial plan, just like I would with a B number table, or just like you may have if you've ever configured Call Manager or Call Manager Express. You need to have some kind of a dial plan that says, if I have an application-specific dial plan, that says if I see SSN6 and I see an IMSI number or global title that starts with 2, he's going to go to the STP that gets me to Europe. An IMSI number, the first number, is a continent identifier. First 3 numbers is a mobile country code. Well, within a mobile country code, the first number identifies the continent. 2 means you're going to Europe. 3 is North America. So 2, go to the STP that gets me to Europe. And this guy could have that logic too until you get to a European STP, and then that STP might have a mapping of all of the country codes in Europe. And then he'd know how to get to an STP that can translate back into a point code to get to HLR. You need to ultimately get to an STP that is doing global title translation that can translate that global title, that IMSI number, and that SSN talking to HLR into the point code of the HLR that you're trying to reach, and have him route at an MTP3 layer to that HLR. So really, MTP3, as you route across the PSTN, might exist in partial legs, almost like the relationship between Ethernet MAC addresses and IPv4 public addresses, where you might have one layer 2 LAN where you're switching, not routing, but switching at layer 2 across multiple switches to get to your upstream IP router, and then he might even be, network address translation, changing hops across. But you don't necessarily have a persistent source and destination MTP3 address, which you don't here, but of course up here you did. You had 111.222 routing all the way across that same header across the STPs to get to the SSP. Well, here you do not. SSN6. So the HLR, when he sees SSN6 with his point code, he's going to go further and say, IMSI number, okay, well I need to look in my database, my authentication center actually. I'm cheating a bit by saying it's HLR. You can actually break it up more modularly than that. So you've got HLR, you've got AUC, Authentication Center. You can say, well, I'm going to get the authentication data for the subscriber, and I'm going to route back. Now he's going to route back based on the calling number that he sees at the SCCP layer. Calling number would be the MSC's global title. Now, network elements like HLRs, MSCs, and these guys would typically be given numbers in the E.164 range for their global titles. E.164. So really, telephone numbers. So you might have, if you're an operator of an MSC, you would have a whole range of telephone number ranges that you can assign to subscribers. Well, you might take a subset of that range and assign it and reserve it for your own network elements. So your own MSC might have a phone number starting with 1 if you're in North America, then 10 digits to identify your MSC. Your SGSM might do the same thing, so that if you need to send traffic across at an SCCP layer with a global title, you can use E164 numbers to reach it across the PSTN. You've guaranteed uniqueness by virtue of the North American dialing plan. And then you have, just as a note too, that IMSI number, that will be E.212, will be the numbering plan for IMSIs, if you wanted to know that. So HLR will send a return back using SSN8. I'm sort of drawing it in different places here. His return back will be SSN8 to identify destination MSC for the reverse path, and it would be a response at a map, would be the application layer map. But in this case, unlike the case we had up here with ISUP, where I said he had a CIC number to map sessions, map doesn't really have the same equivalent. So you would likely need to use TCAP for this. So back to the protocol stack where I say TCAP sometimes, well here, oh sorry, I apologize. The total protocol stack in what the HLR would likely send would be MTP3, I apologize for my mouse drawings here, MTP3 with his source point code, destination point code of whatever STP is going to translate further with the global title. It's going to be doing global title translation. Then it carries along just as it did in the originating path. You'll see SCCP with a destination global title of the MSC, the one that sent the original message, so return to sender, with SSN 8. And then above SCCP, you're going to have TCAP. TCAP is really a transaction protocol. So it's a really simple protocol. All it really does is give a number to identify a series of messages between the two systems. So in this exchange, MSC sends an authentication request, he gets a response. You would map those with a session number called the transaction ID. And that's done at a TCAP layer. That's all it's really doing. And then above that you would have map. You'll also see it written as GSM map. You could actually have ANSI, these guys are kind of competing standards, map and ANSI 41, but I just went with map in this case. So at a map message, it'd be authentication request, authentication response. Great. And then the MSC could send an update location to the HLR. There's a whole bunch of different exchanges that can happen, but this is how logically an MSC would route to an HLR across the PSTN. So across the existing old telephone network, you have this application routing of for telephone signaling, or for mobile telephone signaling, I should say. So with all that theory covered, I just want to talk about Sigtran very briefly, just because it's becoming more popular potentially than old MTP3 direct. So really, Sigtran is an attempt to get SS7 signaling that we just talked about over IP. So it was a body of work by the Internet Engineering Task Force, or the IETF, where they defined a whole series of protocols and white papers. SCTP being one that we've already, again depending on what order you're watching these videos in, SCTP one that we talked about in great length in a couple different videos dedicated to it because it's an important transport layer protocol. And then you have M2PA, M2UA, M3UA. There are actually a couple others, I believe. Those are the main those are the more common ones. What Sigtran really ended up doing was it took transport, pretty much defined it as SCTP for this traffic, and then it took the application layer and really just mapped everything here, pretty much everything in the SS7 suite, right directly on top of the TCP/IP protocol stack. So here you'll have an SSP talking to an STP, but instead of a traditional digital or analog connection between SSPs and STPs, you can use your existing IP infrastructure. If you're a carrier that has both an IP network and an SS7 network, you can consolidate and unify your communications over IP and have an SSP route across an IP router to reach an STP. So you see source and destination IP address terminating at the STP, and then as you cross network elements and go along at an SS7 level, you'd be constantly terminating and creating new IP legs as well. But the protocol stack would be like Ethernet. Actually, I'll draw it out here. So let's say Ethernet between, if you were to look at it on Wireshark, between an SSP and the IP router it's facing towards an STP, you would see something like Ethernet IP. You might see M2UA. Actually, yeah, you would see SCTP as the transport. CTP. And then depending on whether you're using M2UA, M2PA, or M3UA, you'll see it in different stacks. We're going to go with M3UA here, where you really sort of disregard MTP2 and MTP1, and you disregard MTP3 and replace it with M3UA. MTP3 User Adaptation Layer is what that stands for. And then you may have SCCP. And then you may have something like TCAP. Let's see how big I can make this. Then above TCAP you might have something like, let's say RANAP, Radio Access Network Application Part. And I use that because it's sort of tunneling messages for a user, which would be a non-access stratum or NAS message. So it's kind of a leaning tower of RANAP, I guess. It's a really big stack. And if you think this is bad, consider that very often you will have this duplicated multiple times in a single IP packet. There's no limitation within using SS7 over IP and just sending one SS7 message, just sending one SCCP layer or one M3-way layer message. You could send a number of them over IP towards the same STP. Really no limitation. And in fact, very often you will see 5, 10, 20, really dozens of individual, like let's say ISUP, we gave that example for telephone signaling. You could see dozens of ISUP messages in a single IP packet, making it very difficult to trace in Wireshark. Because really you've got CIC numbers, you've got TCAP transaction IDs, but even if you can uniquely map out the transaction ID of a transaction, it might be embedded within very, very large packets with 20 different sessions going on at the same time. And one thing that Wireshark does not excel in is the treatment of multiple values of the same container occurring in multiple instances in the same packet. It's very difficult to map out what CIC number maps to what transaction ID maps to what subscriber number. If you're trying to map to a telephone number or an IMSI number, it can be very challenging in Wireshark. I think I will give a second video on how to sort of overcome those challenges. Basically, the answer is going to be command line and some scripting, some Perl most likely, that I'm more familiar with personally. But there's really no easy answer to doing tracing on Wireshark level with large volumes of SS7 traffic. So that's basically everything that I wanted to cover for this video. I know we've covered a lot. I mean, I can just look at all the different diagrams here. I've gone through a lot of theory and covered a lot of different protocols. Really what I wanted to drive home here was kind of the methodology behind how SS7 routes traffic across the PSTN and how the layers are kind of mapped out and work together. I mean, I've seen like fairly popular, even named sources of video training and even course material and books on telephony talk about this topic really inaccurately, saying SS7 is a signaling protocol, or SS7 is a routing protocol, or a routed protocol. I hope this sort of clarifies SS7 and gives you a bit more of a microscopic view of how it actually works and how these different layers work together. And I also hope that you pick up on and at least become a little bit stronger in some of the terminology here, because this really is some of the core terms that you'll hear not only in telephone but also in mobile. And a lot of times, especially when people are troubleshooting things like M3UA and layers between the IP world and the SS7 world, it can, and I mentioned this is the Tower of RANAP, but this can kind of become the Tower of Babel, where you have some people talking Ethernet and IP. You've got some people talking about M3-way associations and ASPs and IPSPs. And then you get some people talking about the radio and NAS messaging happening and the setup of radio bears at the top of this layer here. So it can really become the Tower of Babel as you talk about different sectors of the industry really represented in different layers of a protocol stack, which is really quite cool, I think. But yeah, so sorry, that is basically what I wanted to cover in this video. I feel free to move over to the next video once you're done reviewing this. Thank you very much for watching.